So in this problem, we need to determine the equation of a parabola with focus at the point 1, -1 and vertex at 2, 1. And also, we need to determine the equation of the axis of the parabola as well as the latus rectum. Let us begin. So what we'll do, first we are going to consider a straight line. And on the straight line, let's say the vertex and the focus lie. So here we're going to consider this point as the vertex having the coordinates 2, 1 and the other point as the focus with the coordinates 1, -1. Now, we are going to choose another point on the same line. We're going to call it point A having the coordinates A, B. Now, the point A has been chosen very carefully. It has been chosen in such a way such that its distance from the vertex is exactly the same as the distance of the focus from the same vertex. Now, the reason why we're choosing the third point A is because we're going to pass another line through this particular point A in such a way that it is perpendicular to the axis of the parabola. So we have a straight line which is passing through point A. That means it is at a fixed distance from the vertex and perpendicular to the axis of symmetry line. So by definition, this is going to be a directrix line. Now, since we are asked to find out the equation of the parabola, we need two information. One is the equation of the directrix and one is the coordinate value of the focus. Here we are already provided with the coordinates of the focus. So our goal will be to determine the equation of the directrix. So let us begin. So what we'll do, we'll first try to find out the slope of the axis of symmetry line, because we are provided with 2 points, the vertex and the focus. That will be an easy task to obtain the slope of the axis of symmetry line. Now we will denote the slope at the letter M1. All we have to do is take the ratio. In the numerator, we'll have to consider the difference of the y coordinate. So let's do the vertex minus the focus. So that means we will start with the y coordinate of the vertex and from it subtract the y coordinate of the focus. Similarly, in the denominator, we consider the difference of the x coordinate. So we'll consider the x coordinate of the vertex and from it subtract the x coordinate of the focus, which is going to give us a value 2. So this is going to be the slope of the axis of symmetry. Now, since the directrix line is perpendicular to the axis of symmetry, we can use the property of straight lines that whenever two lines are perpendicular to each other, then the product of their slopes is going to be -1. So let us consider the slope of the directrix line to be M2. Now, here from the properties of straight lines, we can take the product of the two slopes and this will be equals to -1. Since we need to find out the slope of the directrix line, so M2 will be equals to the negative reciprocal of M1, and we've already obtained the value of M1, that's +2. So that means the slope of the directrix line comes out to be -1/2. So let's call it number 1. Now, to find out the equation of the directrix line, what we'll do, we'll be using the point slope form, which states that if we have a straight line passing through a point having the coordinates x1, y1, and the slope of that line is given, then the equation of the straight line will be y minus y1 equals to the slope times x minus x1. Now in our case, we have the slope of the directrix line, that's -1/2. Now we need to find out the coordinates of point A. To find out the coordinates of point A, we're going to use the fact that the vertex is the midpoint of the line segment joining point A and point F. Since we use the midpoint, so what we can do, we can use the midpoint formula. We'll take the x coordinate of point A added to the x coordinate of F, so A plus 1 divided by 2. And for the y coordinate, we take the sum of the y coordinates of A and F, so that's B minus 1 divided by 2. And this value will be exactly equals to the coordinates of the vertex, that's 2, 1. So when we solve for this, we're going to get the values of A and B. So A and B comes out to be equals to 3, 3. Now that means the directrix meets the axis of symmetry at 3, 3. So now we're ready to find out the equation of the directrix using the point slope form. The equation of our directrix is now going to be y minus y1, so y1 is 3, equals to the slope, which is -1/2, multiplied to x minus x1. x1 is 3 in our case. Let's further simplify. We're going to get 2y minus 6 equals to -x plus 3, and when we rewrite the terms, we get x plus 2y minus 9 equals to 0, and this is going to be the equation of the directrix. So now we have the equation of the directrix line, we have the focus which is at 1, -1. We're ready to obtain the equation of the parabola. So let us begin. So here we have the equation of the directrix, that's x plus 2y minus 9 equals to 0. We have the coordinates of the focus. 1 comma negative 1 lying on the axis of symmetry. What we'll do, we're going to consider a point on the plane having the coordinates x comma y. So point P is going to be the locus of the parabola. It's chosen in such a way such that if we join point P and point F and also drop a perpendicular from the same point P on the directrix, meeting it at M, then by definition of a parabola, the two length PF must be exactly equals to PM. Now here we can find out the length PM by using the distance formula, since we have the coordinates of the endpoint. We have x minus 1 whole squared added to y plus 1 whole squared. Now in order to find out the perpendicular length PM, we have to use the formula which will help us to find out the distance of a point, perpendicular distance of any point from a given straight line. Let's go through the formula. Let's say we have a point P with the coordinates x1 comma y1, and it is at a perpendicular distance from a straight line whose equation is given by ax plus by plus c equals to 0. Then the perpendicular length will be given by this expression where we take the absolute value of ax1 plus by1 plus c divided by the square root of a squared plus b squared. Now that means we'll take the absolute value, and then inside the absolute value we consider the ratio. Now we will start with the coefficient of x of the directrix line, that's 1. 1 gets multiplied to the x coordinate of the point P. That will be added to coefficient of y, which is 2, multiplied to the y coordinate of point P. And then we have the constant term, that's negative 9, divided by the square root of, so here we'll have to take the sum of the squares of the coefficient of x and y. So that's 1 squared added to 2 squared. Now what we'll do, we're going to square both sides. Squaring both sides gives us x minus 1 whole squared plus y plus 1 whole squared. This will be equals to x plus 2y minus 9 whole squared divided by, so here we have square root of 5 in the denominator. Squaring it gives us positive 5. What we can do, we can simplify this, and that's going to give us 4x squared plus y squared minus 4xy added to 8x plus 46y minus 71 equals to 0. And this is the required equation of the parabola. So we've successfully obtained the equation of a parabola. Fine. So now that we have the equation of the parabola, the first part is done. Our next goal will be to determine the axis of the parabola and the latus rectum of the parabola. To find out the equation of the axis of the parabola, we'll use the point slope form of a line, because this axis is passing through the 2 points, the vertex and the focus. We can consider any one of the point, and we already have the slope of the axis of symmetry, which is positive 2. So we will be able to determine the equation. And in the next task, we have to obtain the latus rectum of the parabola. Now the latus rectum of the parabola in this particular case will be defined as the perpendicular length of the focus from the directrix line. That means this particular distance. And since we already have the coordinates of point A, 3, 3, we can use the distance formula to find out the length of AF, and that's going to be the twice that length is going to give us the length of the latus rectum of the parabola. Okay, so let us begin. So slope of the axis of symmetry, we have already obtained its value in equation number 1, came out to be 2. Now let's use the point slope form. We can use either the vertex, coordinates of the vertex, or the focus. We're going to get the same result. So let's use the coordinates of the vertex here. We need y1. So y1 will correspond to the y coordinate of the vertex. This will be equals to 2 times the x minus the x coordinate of the vertex. So that's 2. So here we have y minus 1 equals to 2x minus 4. Well, we have 2x minus y minus 3 equals to 0. So this is going to be the equation of the axis of the parabola. Axis of the parabola. Next, our task will be to obtain the length of the latus rectum. The length of the latus rectum, that's 2 times the perpendicular distance of the focus from the directrix line. That's the definition of the latus rectum, from the directrix line. However, in this case, we don't have to use the perpendicular formula. although you will get the same result because we are provided with the coordinates of point A and point F. All we can do is use the distance formula. So we'll have 2 times the square root of, take the difference of the x coordinate, so that's 3 minus 1, square it, and then add it to the difference of the y coordinate. So we get 3 plus 1 whole square. This will be equals to 2 times the square root of, so 3 minus 1, that's 2, 2 squared, that's 4, added to 16, so that's going to be 20, which is going to give us 4 times the square root of 5. So that means this is going to be the length of the latus rectum.